absolute or conditional convergence. The deal is with absolute or conditional convergence that if let's just read through. Suppose the series that's not that when it says the absolute value of the series, that's talking about like if they give you, well, just one of these. If you put absolute value on this, the negative 10 to the n is going to be obsolete. It's going to go away. It's if it's not there. It could just be like a 10. So if it converges without the alternating part, then it converges absolutely. If the alternating series let me write this out because I don't like the way this is written. And then just write it down and then erase it. If the series would converge if you take the alternating part away. Let me scroll down a little bit. Negative 1 to the n, then it's absolutely convergent. If the alternating series converges, but if you take away that part, the negative 1 to the n, it diverges, then it's conditional. And if the alternating series diverges, then the whole thing diverges. Okay, you can pause that if you need to write that down, because it's gone now. So we're going to look at it. This one, because of the negative 10 to the n, it's going to be alternating. So this is an alternating series. So the alternating series, the limit goes to 0, so it's going to converge. So it's either going to be conditional or absolute. So now if you took this away and you just had 1 over n factorial, that's going to converge as well. If you need proof that that's going to converge, you could actually do the ratio test. I believe it converges because if you think about 1 over n squared, 1 over n squared converges. That's a known series that we know. That's going to grow so much faster than 1 over n squared that it's going to force this to converge by the comparison test. You know what, I'm not even going to prove it. Just trust me. 1 over n factorial is one of the series that you should know that converges. So because this converges and this converges, then it's going to be absolute. It's said to be absolutely convergent. This one, the alternating series converges because the limit goes to 0. So the alternating converges. What if we take away the negative 1 to the n? What about the series 1 over n to the 1/4? Well, this is a p-test. P is less than 1, so that's going to diverge. Because the alternating series converges, but the series, if it's not alternating, diverges, this is said to be conditionally convergent. And then the third one, this is an alternating series. The limit does not go to 0. That's 1, so it's 1 over 1, which is 1. Because the limit doesn't go to 0, then the alternating series is going to diverge. If the alternating series diverges, the whole thing diverges.